Hello, welcome. Let's try to solve another Leetcode problem. 2642. Design graph with the shortest path calculator. So this problem is a typical shortest path problem. So we are giving a graph, but the graph is not giving a complete graph. In the period of constructing the graph, we can add edges. So for example, before it is like this, but we can also add edge from 1 to 3, and then we can calculate the sorted path. For example, from 2 to 3, or from 0 to 3. Before from 0 to 3, there's nothing. But now, if we have a path from 1 to 3, now we have a path from 0 to 3, because 0 to 1, 1 to 3, so the sorted path becomes 6. So this is a typical template of Dijkstra's algorithm. We don't need too much thinking. If we know what is a Dijkstra's algorithm, if we know how to write it, basically we can write it. During the testing time, I used the Bellman fault. As you can see, the Bellman fault is nearly 5 seconds. But while we are using the Dijkstra's algorithm, it is 0.2 seconds. It is much faster. Because for Dijkstra's algorithm, it is n log n time. N is the number of edges, and this n is 100, so n square. So the time complexity would be n square times log n. So it is 10 to the power of 4. But we have another 100 calls, so it means 10 to the power of 6 times log 100. So this is why Dijkstra's algorithm is so fast. But if we use the Bellman fault, so here it's going to be n cubic, and then we have another 100 calls, so it's going to be n to the power of 4. So this is why we prefer to use the Dijkstra's algorithm to solve the problem. Now let's define the graph. So we're going to define a graph of a default list, and inside it's going to be the list. Because we're going to prepare an adjacency list for the Dijkstra's algorithm. So for UV and cost inside the edges. So because it is directed, we're directly going to use gu.append with v and cost. And similarly, we can copy the code from here. Because we need to add add. But how can we add? Let's just try to get the. Let me just copy it. So the UV and C should be equal to this add. We're gonna take it out, and then we're gonna use the GU. So here gonna be the self.gu should append the V and C. It's gonna be the similar, because here is only a single edge, and here is a lot of edges. We also need to prepare this n, because we need to know the number of nodes. So from here, we're gonna use a self.n should equal to this n. Now we can prepare the Dijkstra's algorithm and calculate the shortest path. So we're gonna prepare a priority queue. Inside it's gonna be a tuple cost 0 and starting node with node 1, and also the distance array. So it's gonna be 0 times the number of nodes, self.n. And also we need to prepare the node 1, the distance of node 1. Gonna be starting from 0. Now we can start the Dijkstra's algorithm. So while pq, we have cost with node x would be equal to the heap pop. We're gonna pop the first node from the priority queue, and we can have a check. So if this is C, the cost is more than the distance of x, so we're gonna continue. So we don't need to check that, because this has already been visited. Now we're gonna check all other cases. We're gonna explore the other values. So for V and cost in gx, we're gonna check the distance. So the distance would be the distance x plus the cost. Now we can check the distance. If this distance is less than the distance of y, we're gonna update the y node. The distance of the y node would be updated to d. And we can use a heap push. We're going to push the y node into the priority queue. So it's gonna be a tuple with the cost, it is the distance, and the y naught. Yeah. If we didn't find such values, we're gonna return a -1. But what if we find the node 2? If x equal to this node 2, we're gonna return the distance, and it's gonna be the cost, say. Yeah, so this is gonna be the entire code. As you can see, there's not so much coding. Everything is just about the template, the Dijkstra template. Now let me run it to check if it works. Yes, it should be the self.g because this is a global variable. And let me check if the other, yeah, here should also be the self.g. Yeah, let me check more if there's others or not. Yeah, now let me run it again to check. The edges is not defined. Where is, yeah, here should be the edge, not edges. Yeah, because we have a single edge here, this variable. No, I get the wrong result. This is gonna be difficult to check. Let me try to find. I returned the result with always be -1. It means I didn't find any value. I didn't find any distance. As you can see that the distance is always -1. Even I defined the node distance is not 1. I defined it to be 0. Yeah, but finally I still got a -1. Yeah, let me check. So this is my graph, and this is the edge, and this is the priority queue, and the distance array, and with node 1. If this equal to node 2, I'm gonna return the result, and if this say is more than the distance of x, I'm gonna continue, and then this is inside the graph. Yeah. So the distance is distance s plus the cost. If it is less than the distance y, it's gonna be updated. And here I make a, and here let me think. I put the, yeah, I put the y naught with the cost, and the cost should be d. Yeah, this is the strings. Let me print out the distance array. Let me check what is inside y. Yeah, so my distance array is always 0. So this is gonna be interesting. There must be something wrong. Yeah, because it is here. I defined the distance array to be 0. Definitely nothing would be smaller than 0. Yeah, because all the edges would be positive values. I have to define the distance array to be infinity. So this is a mistake, I believe. Let me try again. Yeah, now as you can see, it works. Yeah, now let me delete the print and check if it can pass all the testing cases. Now as you can see, it passed all the testing cases and it's pretty fast. So yeah, this is for today's problem. Thank you for watching. See you next time.